We're given the derivative is this fraction, and we want to show that f of x is equal to this. So let's first start off with the derivative, and let's break this up into three separate fractions. Each fraction is going to have a denominator of x squared. The first fraction is going to have square root of x at the top, then x squared and 1. And square root of x over x squared, it becomes 1 over x to the 3 halves, or just x to the negative 3 halves. X squared over x squared is minus 1, and then we have x to the negative 2 power. So this is our derivative, and in order to find the antiderivative, I'm going to integrate both sides. So the antiderivative of x to the negative 3 halves is negative 2 times x to the negative 1 half, and then minus x, and then plus x to the negative first power. And finally, we'll add the constant c. So this was just using the power rule. Now I'm going to rewrite this. This becomes negative 2 over square root of x minus x plus 1 over x plus c. We want to rewrite f of x as this fraction. Notice this fraction has an x in the bottom. So if we look at 1 over x, that has the x in the bottom. That's good. This x, we need an x on the bottom, so we're going to multiply it by x over x. And for the first fraction, we're going to multiply that by square root of x over square root of x, because then square root of x times square root of x is just x. So this becomes negative 2 square root of x over x minus x squared over x plus 1 over x plus c. And I kind of wrote over this, but this is a minus over here, just so we're clear. Now they share the same denominator, so let's put that all over the same denominator. And the problem had said to rewrite this as having the x squared in front, followed by the 2 root x, followed by the 1. And they also wanted us to put a negative out here. Okay. So they want x squared. X squared here is negative. So I better put the positive version of it, because this negative is going to apply to the x squared. Next, I wanted the 2 root x. The 2 root x here is negative, so this better be a positive, because a negative times a positive becomes a negative. And finally, 1 here is positive, but I'm going to have the negative being applied to it, so I better put a negative 1 here. And so this is what we wanted to show.